Well, welcome everyone to Better Database Debugging for short Downtimes. I'm Robert Hamel from the Pythian Group, and today we'll learn how to implement simple instrumentation to make everybody's life a lot easier and find your problems as quickly as we can. To give you a little background about the Pythian Group, we're a global industry leader in database infrastructure services for Oracle, Oracle Apps, MySQL, and SQL Server. We have about 150 companies that we do work for, such as Forbes, Fox Force, Western Union, LimeWire. We have one of the largest concentrations of DBAs. We're about 80 plus strong now in our company and still growing, and yes, we're still hiring. People are interested. We're always looking for good talent. We provide real 7/24 global support, consulting, system administration, and special projects and emergency responses. We have offices around the world, Prague, Sydney, Australia, India, and Boston, as well as we're headquartered in Ottawa. To give you a little background about myself, I joined Pythian as October 2000 as DBA. Been the team lead, currently serve delivery manager, and basically I'm running the consulting practice at Pythian. I've been a DBA since '93, obviously not in MySQL, so I do both Oracle and MySQL. I specialize in data architecture, performance tuning, scalability, and to show my Canadian roots, we'll put all the real stereotypes together. Yes, I do make my own maple syrup. The log cabin is not actually my house, but it's our real thing that we built on. The kids are there picking up the maple toffee, and I spend most of the time at my cottage. That's the view I get, and that's what I do most of the time, just dream about MySQL all day. Or nightmares, depending how you want to look at it. So today's agenda, we're going to look at what we're trying to achieve, why do you need to add your own instrumentation, the default MySQL instrumentation, we heard all about that today, the typical troubleshooting checklist that people go through when you're encountering problems, the common issues, simple instrumentation, how you use it, and a few gotchas in 5.1 that pertains to the event scheduler and partitioning. So why are we doing this? Because we're trying to be effective. The faster you get to the problem, the better you are. And why we need to do this? Because the cost of downtime is so high. You need to implement intelligent monitoring. Just having thresholds blow up on you doesn't really do anything. You need to find out what's supposed to run. For example, if you have a batch job that's supposed to run 2 in the morning on a Saturday, and you only check for errors, and all of a sudden somebody deleted the cron entry, commented it out, or took it out of the event scheduler, and you don't notice, and then it affects you 3 weeks later, that's no good. You need to have put some real smarts into it. You also need good instrumentation. You need to know what change as fast as you can. Because as you know, the cost of downtime is so high now, and everybody's breathing down your neck every time there's a problem. And if you can't really, basically throw out all the things like the configuration change. Did somebody add an index? Did somebody drop a table? Did somebody do a load all of a sudden? Was an application released? All those things. You need to be able to dissect that as quickly as you can to get to the real problem. So why add your own instrumentation? Well, we heard today, through the keynotes and a few of the presentations, that MySQL default instrumentation is woefully inadequate. It only shows you what happened, or what's currently happening. It doesn't show you what happened 5 minutes ago, 10 minutes ago, 3 days ago. And why do you need to know this? Well, first of all, your memory is not that great. There's teams of DBAs, developers, and system administrators changing the databases. People are releasing stuff, they're applying patches, they're doing DDL changes on you. Third-party patches can undo some good work that you've done 3 weeks ago by, you add an index, they come in, they drop a table, recreate it, and of course they're not checking to see what you've added. MySQL patches can change default behavior in the database, can change default parameters. Configuration management mistake, you want to do something on system A, you log into system B and do it. There's operating system problems, U limits, hardware failure, a RAID rebuild that you don't know, a sudden workload change, you get an attack. And of course, you can't remember everything you do on every server. Typically today a DBA doesn't have just 1 or 2 databases that they take care of. They may have 50, 60, 100 of them. And in our case at Pythian, we even have 100 customers where everybody is different. So you don't remember who does what when, and it's very hard to do. And let's face it, it's always the database's fault. Always, 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 until you prove them wrong. So you need to find as quickly as you can getting off your back and say, no, it wasn't me, it was somebody else who did it. Hopefully. So, quick look at default MySQL instrumentation. There's not that much. Basically, global. You can see what the current setting of the variables, global status. There's a status showing MDB status. You can view the few logs, query profiler, and now with the information schema, you get an idea of all the metadata, but what's missing. You don't know what's changed. It only tells you the current state of things. So the typical troubleshooting checklist you go through is, you get a problem, check the error log, do a show process list, check the slow query log, look at a few stats, check the OS side of things, check if something changed from memory. You look at the current parameters. Is that what it was? That's what it's supposed to be. You're not sure. You do a few queries on the tables to see if anything's new, something doing a full table scan, is a table growing? Or then the dreaded one, ask around to see if anybody changed anything. They always say no until you find out and they say, oh yeah, but I didn't think it mattered. Right? Everybody's been through that. And the common issues, configuration discrepancies, DDL changes that you're not particularly doing yourself, but somebody's doing it for you. Again, the regularly scheduled drop, as I specified before. People releasing new code and running away on the weekend. Now, none of us have experienced that before. A sudden workload change. Somebody released a piece of software, the users finally found it, and now they start using it. So if we break down the different types and see more details here. The worst thing I've seen on the MySQL side, even on the Oracle side for that matter, is changes to configuration parameters, either in memory or in the my.cnf, and you don't update the other side. Every time you bounce something, you do a planned maintenance where you shut it down, bring it back up. Sometimes it doesn't affect you. It might take you a few days to figure it out. This change can be 6 weeks ago, 6 months ago, and you might get hit with it suddenly. Changes meant on one database, again done on the other. Applying MySQL patch, I got hit with that a few years ago where we applied a batch and changed the default value. And it had adverse effects on our database, but I didn't know what it was because I looked at my my.cnf. I hadn't changed in months, so what could it be? How to resolve these things? You need to track historical change. And how long you need to go? As far as you can. There's no sense going back 30 days. If the change you've done was 6 months ago and you only keep a my.cnf, you back it up for 30 days, keep the last 30 days and blow the rest of them away. Sometimes you have to go farther than that. And we got hit with that, and it doesn't matter what database technology it is. And you need to monitor for discrepancies. At Pythian, we do this very well. We have something checks every day. Does the my.cnf match what's your memory with the current active configuration? If not, we flag it because it's something that's going to bite you in the butt days or months ahead of time. On the DDL changes side, well, there's always somebody's putting in a new table, doesn't index it. Again, applying on change on a reporting database that's meant to be on production. Third-party application patches, you get some third party, you went in and did some nice index work, all this tuning, and then they come in and they upgrade their version and undo everything you did. Again, you need to track the historical changes. How far? As far as you can. The problem with this one as opposed to the configuration parameters, there's a whole lot more here. You have to track tables, you have to track indexes, and the order of the columns in the index. So there's a lot more data to capture. And remember, sometimes it's not what's changed, it's what's no longer there. And like we saw this morning, somebody dropping an index of the keynote with Oracle, that is sometimes more important than what's the one's been added, because you need to know what's been removed. There's nothing worse than blowing away an index and wondering why our query is slow. On the regularly scheduled jobs, we deal a lot with failures that go unnoticed. And this is either through cron or the event scheduler. Things don't run at all, or have been removed without you knowing about it. They exceed the prescribed runtime window, so they run a whole lot later than they should, and you have a backup running in the middle of the day all of a sudden because somebody decided to change the schedule so they didn't want to get patient night when the backup failed. And all of a sudden, you hit prime production, there's a backup running. Or they want to do a copy for a development database and they run it at prime time. The resolution here, you have to do some kind of job logging for tracking history. The event schedule in cron doesn't have that built in. You have to build it in yourself to find out what's going on. And you want to monitor what's supposed to run, than just the errors. So, we typically like to have something, if this thing is supposed to run weekly, well, I check to make sure I have a successful run of this job in the last 7 days, that kind of stuff. And you can monitor the current executions against the baseline. If this thing's supposed to run 5 times a day, make sure it runs at least 5 times a day. It's supposed to run within 15 minutes, make sure the execution time runs within 15 minutes. Just don't wait for errors, because it's not going to help you for performance problems. On the new or changed queries, well, obviously bad design. Well, you can't do much with bad design. You can tune your way out of it sometimes, you can change a few parameters, but at one point you can't do much with that. Suboptimal execution plans, obviously if somebody creates a new table, you start getting a whole bunch of full table scans as the table grows. Eventually, things start spilling to disk and then all hell breaks loose. Using the wrong indexes, somebody changed the sort criteria and all of a sudden you can't use the index, it has to go out to disk and do a file sort. And of course, all the locking scenarios you can get into. Now, obviously, I'd like to say that a DBA can look at all the query plans before they go in production. It never really happens. And it's hard to fix after the fact, let's be frank about it. And it's really important to do testing with proper volumes, not just say, yeah, I did an execution plan, it looks okay, or I ran one. If the thing is supposed to be built for 40,000 users, well, try to run it for 40,000 users, see what happens, because you'd be surprised what you hit. You might hit an index problem, you might hit a database or concurrency problem, even an OS setting that stops you from running this stuff that you don't know until it's too late. The ideal would be to track execution plans and workloads historically, and you want to monitor key performance against the baseline. So you take some key queries, grab what's normal, and then monitor against it. I know a lot of people will just go by the slow query log, and obviously not everything in there is bad, and not everything that's bad is in there. So if, for example, a query that runs once a day takes 5 minutes to run, it's 2 in the morning, who cares? And something that runs in half a second, but you're running 1,000 of these things a minute might be a problem. So workload changes. Again, same query, all of a sudden the table starts exploding exponentially. You increase the concurrency of the query, so more users are doing it. You're hitting database limitations. You have application configuration problems. All of a sudden, the web servers start connecting to your database like queries. There's a new workflow you weren't expecting. There's a hardware failure. A disk dies. You have to rebuild a RAID set, so that's going on in the background. All of a sudden, your database starts slowing down. Somebody decides to do a big copy, a big backup on the network, all that kind of stuff. Again, the resolution here is you're not going to really fix it. The only thing you can do is identify that, okay, something else is causing me grief. There's not a whole lot you can do about it, unfortunately. Again, you need to track your database metrics, your OS metrics, your query performance, and you need to track your growth over time. You're just trying to do pattern matching here at this point. You try to identify where the problem happened. Is it sudden? Was it something that was building up over time? They can help you to diagnose the problem. So, tracking changes over time. For your config files, a lot of people do daily copies, keep the last 30 days. They dump show global variables daily, keep in the table forever. For the DDL, a little more complicated. People typically will do a MySQL dump of the structure, keep that. You might want to copy the information schema, keep that for a few days as well. The problem with these approaches is, when it's time to actually go through the stuff, every type of data you have is a little clumsy. The queries are a little different. You end up repping something, querying other things. And some of this data can really add up, especially on the DDL side. If you do a lot of changes, that can, especially since you dump everything, it can really add up to a lot of data, and I'm talking gigabytes real quickly. So how do we do it? Well, we're stealing a page from the data warehouse modeling side, dimensional modeling, and we're using what's called a slowly changing dimension type 2, which basically tracks history. And basically the advantage that this gives us is you start with the baseline and you only track what's actually changed. So basically you can keep the data forever without consuming any space. And the functionality it gives you, you can run out, I listed here a few of the typical queries that it gives you. You can basically do what's changed since X, yesterday, the day before, last week, last month. Track a historical parameter over time. Find out what was everything set to last February, exactly to what it had. What's disappeared since a certain time. The current state of a DDL object, and you keep going. So. Because the nice thing about this approach is no matter what you track, parameters, indexes, tables, even changes to triggers or stored procedures, the same queries give you the same type of information. So if you want to see what was the current state of the system yesterday, you run the same queries on all of these objects, and you get the results. You don't have to say if it's tables, I need to do this. If it's configuration, I need to do that. So what do you need to actually do this? Well, you need the primary key of the original object. And here what I'm thinking is using the information schema to extract the info. You need to identify which attributes you want to track the changes on. And then you're adding a little metadata for the slowly changing dimension part. You need to add a row effective date, which is basically when the first time you found it, the end date, which is the last time you saw it, and the current flag is, okay, this is the current value. To actually do this, you can develop a script, stored procedure, cron. You can write it in anything, it doesn't really matter. You can schedule it any way you want, it doesn't really matter. As long as you actually have it, and you can run it before and after maintenance activities to get it more granular. The more often you run it, the better data quality you get, obviously. So if you look at the algorithm for this, it's fairly simple. You basically compare the current value against the PK. If it's something you haven't seen before, you insert it, set the current flag to say this is the current one, row effective date is now, and row end date is a date way in the future, hopefully after you retire. And in my case, it's 12 years, so anything after 12 years, I'm good. If something that's changed, basically you update the current row and say, okay, it's no longer current, the row end date is now, which means this has changed, so it's no longer effective, and then insert the new row. If something that's been removed completely, you basically just set the current flag to nothing, update the row and date, and leave it alone. So for an example, we'll do the global variables, just to give you an idea of what this thing looks like. So for the table, it's basically variable name, variable the value, the 3 columns. The PK here is really the variable name and the row effective date. Obviously, there's only one thing set to current at any one time. So if we look at the initial population, and I picked the first 4 variables I saw in the show global variables. Basically, we insert the raw values, the row effective date is set to when I ran it, and then the row end date I set to sometime in 2038, current flag to 1. If you do a change to one variable, and here I don't know if you can see the bold too well, but I changed the auto increment value from 1 to 2. And what would happen there is on the resulting table, the row end date would get set. The current flag gets set to 0 as the update, and then a new row is added at the bottom with, to say, the current time that I saw something 5 minutes later, and then the row end date is obviously way out there. On a deprecated variable, and this would happen, for example, when you upgrade from one version of MySQL to another, where certain parameters names would change all of a sudden. And if you didn't change it in your my.cnf, you're going to get default values for some of these things, right? So what would happen here is that on the log side, the row end date gets set to 0. There's no new variable for it, and then the general log would be added in there. And the queries you would use to get some of the questions we've been asking is what the current state of the values. Obviously, just take everything where current flag equals 1. Historical changes to any parameter is basically pick out everything where the variable name equals whatever, order by row effective date. If you want to show configuration in the past, you just basically select the variable name, the value, where the date is between row effective date, row end date. You're only going to get one value for each. And so you can get the state of things yesterday, last week, 3 weeks ago, 10 minutes ago, depending on how you run it. Fairly easy without having to go grep and try to assemble things through files. Other things as well is what's changed, which means what's been added. So you look at anything with a certain date with the current flag to say what's changed since, whatever. On the other side, what's been removed to date. So if you do something like did somebody drop an index that said where some DDL got removed, you can do that with this by just going on, show me what's no longer current that's changed since the last time. Now the next thing we're going to be looking at is what I call a job log. And this is for stored procedures, especially if you're doing it in the event scheduler. The idea is to add some instrumentation, because with the event scheduler you don't really get much. You can say if something's currently running, if it failed, but it doesn't tell you, how it ran the last 10 times or how fast it went. So basically here we're going to add a little metadata we're going to have something called job master, a job logs, and a job config table. We're going to add a few functions and procedures. So adding a job, and we're going to step through it, update a step, completing a job, and then we'll go through a few examples of how to monitor and troubleshoot with this metadata. So if you look at the tables are pretty simple. We have something called job masters, and it's basically job ID, job name, which is basically an instance of something that's running, where you store procedure name, a timestamp, a completion status, completion timestamp. On the job logs, it's basically we're doing the individual steps, and in there it's basically you can break down a procedure and have the individual portions that you want to track. So you don't want to say the job took 10 minutes. You say this step took 50 seconds, this one took 3 minutes, so you basically have an idea of where time is taken in your store procedures. The job config table, this is basically for the better part of the monitoring, which basically tells you, especially if there's certain jobs you don't want to get paged in the middle of the night because you don't really care. All you care about is they ran 3 times successful last time, even though they're especially if they're restartable. So in here you can basically say how many minimum successes or maximal failures you're allowed to have before you trigger an alarm. And notice in bold the engines, and this is important that you have to pick something that's non-transactional, because if your store procedure is dealing with an ODB data, and you actually you have exceptions in your store procedure and do a rollback, well, if these tables are in ODB, you're going to roll back all your instrumentation and you'll get nothing and wonder what the heck's going on, right? So you want to keep it like that, and that basically makes it an autonomous transaction, so even though you commit or you roll back, the instrumentation data stays put. So for the procedures, what we're looking at is basically 2 functions, 2 procedures. We're going to add a job. It's basically just simple stuff. We're going to add a step, update a step, which means completing the step and then completing the job on top. And for the example of it in the code, basically what we're looking at here is we're creating a handler, which is called basically, we're updating the step. And in MySQL, unfortunately, you can tell the error class, but nothing gives you an actual error number. So you can't really find out exactly what it is unless you list them all out. So you have to leave it like that. I'm sure that's coming up in the new releases, since it's their first real release with proper store procedures. You basically set your job name, you add your job, and then for every step where you want to track how long each individual part of the code takes, you basically just add a step, and then you update the step at the end. If you get an exception, it comes back to the exception tablet, tells you it's an error and gets out, and at the end, you do job logging complete, and basically that just sets the status properly. Now, if you look at the different monitoring we can do with this, you can identify jobs that ran successfully, or should have run at all. You make sure that your actual successes are greater than your mean successes. Checking for jobs that failed more than that were allowed or what you wanted to. Again, actual failures greater than max failures. You want to identify what exceeded the execution time. So that's, again, a little more intelligent monitoring where you're making sure that the actual completion, the actual elapsed time that it takes to run a job is less or equal or less than the prescribed time. Or if it goes greater than that, then you got a problem. Then it might be something you want to look at. And you want to say how things went yesterday, how it went over the weekend. You can basically grab the status and count star from all. And we actually use this type of monitoring at Pythian as well too. We do like daily runs, so we see all the jobs executed. We do this for Oracle and MySQL as well. Now on the troubleshooting side, we're looking at performance over time. And basically, you pick a specific job, run it through a timestamp. You can actually wrap it in Excel. So it basically helps you finding out if things are getting worse. Was it a sudden thing that happened? Or it's basically incremental. It's basically the same thing as gathering OS metrics and querying them through Cacti. It gives you an opportunity to do that. You can do complete job executions. You can order it by steps, so you see exactly what happened when, so you can find out how long certain parts took. And if you want to compare a particular step of a job versus the same step last week to see if this is the portion that's getting slower, you can really drill down to the details. And the amount of steps you put in really determines how granular these things are. Now, when you query metrics over time, the idea is to track the queries and processes. So you want to track how many executions, how many rows you've read, rows returned. The ideal would be as well grabbing execution plans, and you want to monitor that against the baseline. And it's best done through the web logs, or at least at the application level, because it's the end user experience that really counts. It doesn't really matter if the database query takes 3 seconds. If the overall process takes 30, and you tune the query from 3 seconds, and you get down to half a second, you think you did a great job, but the user is still looking at 25 seconds, thinks the system sucks. Or it limits the amount of querying that you can actually, or the amount of tuning that you really need to do if it's only 5% of the overall workload. And really, it's the only KPI that matters. It's the user experience. On the database in OS metrics, it doesn't really matter how you collect it. Cacti, the MySQL Enterprise Monitoring, or any other third-party tool you want to use. You want to keep in the database, you want to dump it in files. The idea is to capture metrics at regular intervals. You want to grab the show global status. You want to go grab stuff in the information schema to keep track of how big your tables are growing over time. You want to grab some variant of OS statistics, SAR, VNS output, or anything else you want to grab. And you're looking for patterns. You can use, like if you use a graphing utility like Cacti, that's fine, or you can just grab the raw data in tables, bring it into OpenOffice, graph it, and then you're looking for a sudden change in patterns. And again, you can use this to find out what is considered normal, add a few standard deviations to make sure you don't just grab outliers, and then you can monitor that against a baseline as well. Now, event scheduler considerations. It runs like Cron, and I found that out the hard way. I thought it ran like the Oracle job scheduler, where it doesn't repeat itself. It actually waits for the job to finish before re-executing. In this one, it doesn't. I basically brought a production system down real quickly by running a job every minute that took 5. So I had 1,000 of these things running and basically just brought it down. So what I had to end up doing is add explicit locks in the procedures to make sure I'm already running, don't run again. And to give you an example of what that looks like, is basically you declare a lock string, which basically is just a name, it's a label. And if you look at the set vlock, you basically do a get lock. You put the amount of seconds you're willing to wait. If you get the lock, it'll say, if you don't get the lock, it'll come back with a 0. Then you exit gracefully. You did get the lock, you execute the rest of the procedure, then you say release lock. That way, if the job just comes back and wants to run again and it's stuck on something, it won't actually make the problem worse. We'll just die out. You just wait timeout and get out of the way. And that saved my bacon a few times. On the partitioning side, the experience we had in partitions, I've been doing partition with MySQL since it came out, but a lot of this experience comes from the Oracle side where partitioning and the same type of partitioning was available for several years. Yes?
You could please go back to the previous slide.
Yeah.
Where do you set the lock in this one?
The lock is when you do a get lock. That's where that's how you acquire it, so it's set. And if you try to do a get lock again on that, and you put a lock string and say 3 seconds, after 3 seconds, if that lock's not released, it'll time out, it'll come back with a result equals 0, as opposed to a 1.
So if it dies after getting a lock, and job dies after
well, this is an instance of, so in the event scheduler will release it anyway. If you're running a code and it dies, I think it releases the lock. I'd have to confirm, but I'm pretty sure it releases the lock if the session goes away. All right, we're good? So on the partitioning side, one thing I found out a few weeks ago is, and find out the hard way, is MySQL will lock all the partitions to insert even a single row. If you have a table with 1,000 partitions, which I was trying to have because of the amount of data this client was trying to have, and we're trying to bulk load a lot of data, it would just issue every row and get 1,000 blocks. So if you have a lot of partitions on your tables, don't do single row inserts. Try to do them in batches of 5, 10,000, 20,000, or the higher the better, because you will have that lock overhead. Obviously, it's very bad for concurrency on the HAS and list partitioning side. If you're thinking of list partitioning, node 1, node 2, node 3, and you try to get some concurrent threads in there, it will lock them all anyway, so you're not really getting that benefit. On the partition maintenance is very important, and it only happens obviously on range partitioning. And that is the most important thing you need to do with range partition. Make sure your partition maintenance actually works. I'm sure there's about 60, 70 of you in here. I'm sure that at least 1 or 2 will go back if you're using partition and you notice that you don't have any partition maintenance. Somebody defined 12 months of partition 7 months ago, and it's just running. And what's going to happen is, on a Saturday, obviously it's not going to be either probably on Thanksgiving weekend. or not the first of the month, depending if some monthly or daily partition is going to hit you at 12:01, when somebody's going to try to insert a row, it's going to die. Again, you have to remember you only have 1,024 partitions, so as you add them, you have to remember to actually remove them. So we typically do it with the sort procedure. We try to keep so many ahead, so many back, and you monitor. And the way we monitor it is we insert rows in the future, like 3 or 4 days, typically to go over a long weekend. So if you can insert something 5 days in the future every day, that means you're probably okay for the next 5 or 6 days, so you can survive that. The other thing I want to bring in as well is the max value partition. It seems like a great lifesaver, but I hate it with a passion, and it gives you a really false sense of security. And this is an exact problem that happened on an Oracle database that we had like 5 or 6 years ago. One DBA creates this nice daily partitions, creates about 6 months of it, and didn't have partition maintenance, but it had the max value. So about 7 months later, we noticed the database starts slowing down. And basically what happens on this graph here is you have this nice partition maintenance, and you base your table design and your index design based on that. And then all of a sudden your max value grows and grows and grows. I'm pretty sure and in this case, it ended up being about 80% of the table. So all of a sudden now you're dealing with a single table again. Client wasn't too happy because we needed to do some maintenance to fix it. And we weren't too happy because of all the performance design we built in with the partition got all washed away because of the max values. So at Pythian, we typically stay away from max values. We add our intelligent monitoring, and we try to push it ahead like that as much as we can. So that's basically it for the talk. If you guys want to bring your business cards, we're going to have an autograph copy of Sherry's new book, and she's even here to probably raffle it off.
Put your name in it and stuff. And we also, if you do leave your business card, we'll put you on our mailing list forever. You can obviously get off of the mailing list or whatever. One thing we're going to do is we're going to send a sample chapter of the book out. And when I say sample chapter, it's 80 pages. It's how MySQL extends from standard SQL and how it deviates from it. So it's worth it, particularly if you don't win the book itself, yes. I think.
Any questions? Was that clear or that confusing? Yes?
You know if your presentation will be posted?
Yeah, I think the MySQL, I think they post the presentations after the talk, or if not, we can send a...
we can send, actually, we'll probably end up sending the slides out too in an email or a link to where the slides are. That would make sense to do.
Yeah, and we'll post it on the Pythian site somewhere.
Yeah, they'll be on, if you read Planet MySQL or anything like that, then you can do that, or you can take our business cards and you can email us next week and say, can I have those slides? And we'll just email them to you if you don't read Planet MySQL.
Yeah, and if you want to add some sample source code, just give me your business card and tell me you're interested, and I can send you some sample source procedures of some of the stuff in action, if you guys are interested. Anything else? Going, gone. Great. Well, thank you very much, guys.